Alright, Chapter 1, Section 2 in Geometry is measuring and constructing segments. Alright, you got definitions are coordinate, distance, congruent segments, midpoint, and segment bisector. There are two postulates in the section, but we're only going to use one of them. That's the segment addition postulates, 1-2-2. Okay, so starting off, we have coordinates. Okay, and what a coordinate is, it's the position of a point. So I have a grid here to show what a coordinate looks like. Okay, I'm going to plot 2 points here. I'm going to plot -3, 0, and I'm going to plot 5, 0. Done. Alright, I'm going to name these so we can see. Label plotted points. Okay, so I have point A and I have point B. Now, their coordinates are, again, -3, 0. So I can plot, graph, measure coordinates, measure B, okay. Now, since they're in a line, I can pretty much just count the squares and see how far apart they are. Okay, so it's 1, 2, 3, 4, 5, 6, 7, 8. Okay, it's real easy. Now, distance. Okay, distance is just the absolute value of the difference between the 2 points. So if you see here, -3 and 5. If I subtract those, -3 minus 5 is -8. Well, you can't have a negative distance. So you take the absolute value. So it'd be 8. Okay, so this would be 8 centimeters. I can even measure it. A to B, measure, distance, 8 centimeters. Okay, when we're talking about segments, okay, the distance is a length. Okay, so that's the measurement that we use. Distance is a length. Okay, so that's what a coordinate is, and what distance and length mean. All right, now I'm going to get rid of the grid. Delete. Now we're going to talk about congruent segments. Okay, and what congruent means is that it has the same measure. So in this case, when we talk about congruent segments, we're talking about segments that have the same measure, the same length, the same distance. So I'm going to draw a segment here. I'm going to copy the segment. I'm going to paste. So I have 2 segments here. All right, let's label them. Display, label points. Okay. Points. Display, label points. Okay. All right, so I have segment CD and I have segment EF. Now, right now I don't know they're congruent. Obviously, I copied and pasted them, so they should be. But if I measure them, measure length, the measure of segment CD is 14.25. Measure length, the measure of segment EF is 14.25. So these are congruent segments. Now, in order to show they're congruent, I draw tick marks. So since this CD has 1 tick mark and this EF has 1 tick mark, they're understood to be congruent. Even if I didn't give you the measurements, if you see a tick mark and a tick mark, they're congruent. That means the segments are congruent. Okay? Alright, next thing. Alright, I'm going to scroll down a little bit and make a new segment. We've covered coordinates and distance and congruent segments. Now we need to talk about midpoint and segment bisector. Alright, I'm going to label these points so I can name my segment. That won't work. Okay. Alright, I have segment GF. Now, a midpoint is basically, the definition is exactly what the word means. It's the middle point. It's the midpoint. So, it's going to split G and H into 2 construct, there we go, midpoint. It's going to split G and H into 2 congruent segments, because I can go ahead and do this. If this middle point is the midpoint, then the distance from G to the midpoint is going to be the same distance as from the midpoint to H. So therefore they're congruent. They have the same distance, the same length. Let me name this point real quick. Display label midpoint. Alright, it's midpoint I. So if I want to prove it, G to I, measure distance 7.87, measure the distance between I and H, measure distance. There you go. And if you notice up here, G and I and H and I, or I and H, there's no line above it. If there's no line above it, that means distance. It means the distance from G to I is 7.87. The distance from I to H is 7.87. Or if you scroll up, if you see how it put the M and then line segment, that means the measurement of. Okay? So either one of these is a way to label the distance. Alright? So we have the midpoint I here. So a midpoint basically splits the point in half. So if I said that we have a midpoint on a segment, then you can draw your tick marks because the segments are congruent. Alright, next thing. We have what we call a segment bisector. Okay? A segment bisector is a ray or a line or a segment that runs through the midpoint. Okay? It splits the segment in half. So if I'm looking at segment GH right here, if I draw a line, construct, alright, a line, label this point, so I have line JI here. Since line JI runs through the midpoint, we say that line JI is a segment bisector of GH because it goes to the midpoint. And if you notice, I can move it any way I want, it still splits GH in half. Okay, it still splits it in half. Alright, I can do a segment if I wanted to. I can delete the line, draw a point, here and here, construct segment. This segment here, from this point to I, is not an angle bisector, it's a segment bisector. It touches at I. Even though it doesn't go all the way through it, it's still considered a segment bisector because it splits G and H in half. I could also form a ray, and it does the exact same thing, still splitting G and H in half because it runs to the midpoint at I. Alright, so things we've covered so far is coordinate. It's the location to the point. Distance is the absolute value between the 2 points, or the length. Congruent segments have the same measure, so they have the same length. Midpoint splits a segment in half. And a segment bisector is just a ray or a line or a segment that splits another segment in half by running through its midpoint. Now, note, a ray and a line cannot have a midpoint. They cannot have a midpoint because where are you going to cross or put a point on a line that's in the middle of it? It extends on forever, so therefore you can't have a midpoint on it. You can also not have a midpoint on a ray because it extends on forever in one direction, so therefore there's no midpoint on it. Midpoints are only on segments. Okay, now we're going to go on to the postulate theorem. Alright, the segment addition postulate theorem. Alright, and what it says is if I have a segment here and I place a point on the segment right there. So let's label all these points. Construct, or excuse me, display, label points. Okay. Right, I'm going to need to know the distances for this. So I'm going to find the distance for L and M. Construct or measure distance. The distance between L and K. I need to know it. Distance. And the distance between K and M. Alright. If you notice, L and M, LK, and KM. LK and KM make up L and M. So if you add number, calculate, if I add up LK plus KM, then they're going to equal the entire length. And that's what the segment addition postulate states. If there is a point between two values or two other points on a line, then these segments formed, so LK and KM, will add up to the total length of the segment. So LK plus KM equal LM. Look at this, 18.07, 18.07. If I move K up and down, you notice the distances for LK and KM change, but when I add them together in the total distance here, never does. You see that? All the way across, they never change. So if I know each individual part to a segment, I can figure out the total of the entire segment. And that's what the segment addition postulate does for me. I'm able to add up all the individual parts to get the total. Okay. So that is all for section 2 in chapter 1.